Welcome guys to my YouTube channel today. In today's class, we are going to be looking at stoichiometry part 2. And in this lesson, we are going to be looking at mass to volume relationship. Don't forget, in our previous videos, we discussed about mass to mass relationship. And the second type of stoichiometry is what we call mass to volume relationship. Now, let us take a look at this question from JAM 2004, question number 33. Let's read this question together. What is the volume of a gas evolved at STP? The first thing they mention in the question is the volume. Please take note of this. It must be noted. Note this. Note it. So they talked about the volume of a gas evolved at STP. Okay? If 2 grams of calcium triazocarbonate fall, now the next thing they mentioned was 2 grams, and grams is units of mass. So that is to say, the next thing that was here that we need to note is mass. And this is the reason why this particular question is tagged as what? Mass to volume relationship. But before we solve this question, it will be important for us to bring out the chemistry of the reaction. Let's do that quickly. Now, watch this carefully. They said that ACl, what is the volume of the gas evolved at STP if 2 grams of calcium triazocarbonate is added to a solution of hydrochloric acid? So it's a chemical reaction between calcium triazocarbonate and hydrochloric acid. So we have calcium triazocarbonate, which is a solid, plus hydrochloric acid in aqueous medium to give us what? Calcium chloride plus H2O plus the gas evolved at STP. So this must be noted. Please take note of this. The question talks about the gas evolved at STP, and the only gas here, this is aqueous, this is liquid. The only gas here is carbon 4 oxide. So they want us to focus on carbon 4 oxide. Number 1. They say, what is the volume of the gas evolved at STP? So carbon 4 oxide is very, very important in this particular question. If 2 grams of calcium triazocarbonate fall, so they gave us the mass of this guy. Do you understand? So our focus is calcium triazocarbonate and carbon 4 oxide. In carbon 4 oxide, they talked about the volume. But in calcium triazocarbonate, they said if 2 grams, so they talked about the what? The mass here. So this particular problem is called mass to what? Volume relationship. I have told you before in my previous class that when you are given a problem like this, the first thing to do is to identify the problem, and this particular problem is mass to volume. So when you are done with that, you have to calculate for the molar mass of the compound where the mass was mentioned first, and you get the volume of the compound where the volume was mentioned. So don't forget that at what? Standard temperature and pressure, gas molar volume is the volume occupied by 1 mole of a gas at STP is equals to 22.4 dm3 or 22400 cm3 in the unit of cm3, while this is the unit of the volume in dm3. So you must understand that for every 1 mole of a gas, it occupies this volume. Okay, so how many mole of carbon 4 oxide do we have here? 1 mole. So that means the volume of carbon 4 oxide here is 22.4. But if you look to the option, you see that the options are given to us in words cm3. So we are not using 22.4 either. We are using 22400 cm3. So that is why we have 22400 cm3 in the unit of what? cm3. Parameter, we have 2 moles here. We would have multiplied this value by 2. And if we have 3 moles here, we multiply the value by weighting at 3. So because we have 1 mole, that's why we leave it that way. So you must take note of this, okay? So you have mass here and you have volume there. Now that we have mass here, class, what do we do? All we have to do is to calculate for the molar mass of 1 mole of the compound. Let's calculate the molar mass of calcium carbonate. CaCO3. Calcium is 40 plus carbon is 12. Oxygen is 16 times 3. So you have 40 plus 12 plus 48. That will give us 100 gram per mole. So the molar mass of calcium triazocarbonate 4 is 100 grams. So if you had 2 moles here, I would have multiplied this with 2. If I had 3 moles, I would have multiplied with 3. So, but because we have 1 mole, we can say that 100 grams of calcium triazocarbonate 4 was able to liberate what? 22400 cm cube of carbon 4 oxide. So if you have done this, the next thing to do is to go over to the question. The question says that what will be the volume of the gas evolved. So we are looking for volume of carbon 4 oxide. If we have 2 grams of calcium triazocarbonate 4, so that means I'm going to put 2 grams here to give us X volume in cm cube. So what do we simply do now? Cross multiply. And when you cross multiply, you use your X to multiply 100. So you have 100X equals to, use your 2 to multiply 22400. So you have 22400. So what do we do now? Times what? Times 2. We're using this 2 to multiply this guy. Then we divide both sides by what? 100. 100. This cancel this so that your X will give us what? 0 cancel 0. 0 cancel 0. 224 times 2 will give us 448 cm cube. So the volume of carbon 4 oxide evolved at STP when 2 grams of calcium triazocarbonate 4 was added to a solution of hydrochloric acid is 448 cm cube. So the answer is not A, the answer is not B, the answer is not C, the answer is what? D. Okay, thank you very much. Let's take our next question. Now let's take our question number 2. According to this question, in the reaction calcium carbide plus water gave us slake lime plus ethyne. According to the equation, what is the mass of solid calcium carbide needed to produce 1000 cm cube of ethyne gas at what? STP. Now let us copy the equation for the reaction first. We have calcium carbide CaC2 plus water. Okay, this one is solid plus water, 2 moles of H2O, which is what? Liquid. Now give us what? Slake lime, calcium hydroxide. Now, plus your ethyne. This gas is called ethyne. Ethyne. Now look at the question. In the reaction, this is the reaction. What is the mass of solid calcium carbide? So here they are talking about weighting, the mass. You note it down. Needed to produce 1000 cm cube of what? Ethyne gas. This one is a what? A gas. This one is aqueous. So what is the mass of solid calcium carbide? You are talking about mass here. Needed to produce 1000 cm cube. Your cm cube signifies what? Volume of ethyne. So here they mention the volume. So that is the reason why we can say this particular question is mass to volume relationship. So we can simply establish that mass to volume relationship. Before we proceed further, it will be very important to see if our equation is balanced. Okay? Now you have 1 calcium here, you have 1 calcium. 2 carbon, you have 2 carbon. 4 hydrogen, you have 2 hydrogen here, 2 here, 4. 2 oxygen, you have 2 oxygen. So the equation is balanced. We can solve the equation. First of all, we are going to get the molar mass of this compound because they mention mass. And here we are going to get the volume of 1 mole of ethane. Don't forget I told you, for every 1 mole of a gas at STP, standard temperature and pressure, you have a volume of 22.4 dm cube for every 1 mole, or you have 22400 cm cube in the unit of cm cube. Now we are going to work with this. Why? Because according to the question, we were told that 1000 cm cube. So the unit here is in cm cube. So that's why we are working with 22400 cm cube for every 1 mole of a gas. So if I have 2 mole, I will multiply by 2. And if I have 3, I'll do the same. So here we need mass. But here we need weighting, volume. So what is the molar mass of calcium carbide? Let's do that quickly. The molar mass of calcium carbide, CaC2, is 40 plus carbon is 12 times 2. So you have 40 plus 24 to give us 64 grams. It must be no. So this is the molar mass. If we had 2 mole here, we would have multiplied this guy by 2. And if I had 3, the same thing. So you have 64 grams of calcium carbide gave us, what is the volume here? For every 1 mole here, you have 22400 cm cube. So if parameter we had 3 moles, that multiplied by 3. So now the question says, what is the mass? Look at it. What is the what? Mass. So we're looking for mass here, S gram. That will be produced what? 1000 cm cube of ethane. So we compare it to 1000 cm cube. Wow, very easy. So what do we simply do now? Cross multiply. When you cross multiply, use your 1000 to multiply 64. So you have 64 times 1000 equals to, use your x to multiply 22400 times x. So what do we simply do? We'll simply divide both sides by 22400. So do your day by 22400, divide here by 22400. So this cancels this. First of all, we have x equals to, by the time I multiply 64 by 1000, I will have 64,000. Then I'm dividing with 22400. So let's do that quickly. 64,000 divided by 22400. Your answer is equals to 2.86. What? We're looking for mass. Grams. It must be noted. So stoichiometry is very easy. Let's take question number 3. Question number 3. Phosphorus reacts with oxygen according to the following equation. What volume at STP would be required for the complete reaction of 12.4 grams of phosphorus? Okay, now take a look at this. There's a chemical reaction between phosphorus and what now? Oxygen. Let's bring out the equation for the reaction. Phosphorus is a polyatomic molecule, so you have P4 plus 5 mole of oxygen gas, so that it gives us P4O10. Now there's a chemical reaction between phosphorus and oxygen, and according to the question, they said phosphorus reacts with oxygen according to the following equation. What volume at STP will be required for the complete reaction of 12.4 grams of phosphorus? So we are looking for volume of oxygen that will completely react with 12.4 grams of phosphorus, which signifies weighting, mass. And that's why this particular question is tagged as mass to volume relationship. I've told you countless times in this class that you must establish a relationship between the mass and the volume. So what do we simply do? First of all, I have told you that 1 mole of a gas at STP is 22.4 dm cube in the units of dm cube, or 22400 cm cube in the units of cm cube. Now, we are looking for volume of oxygen required for reacting with what? 12.4 grams of what? Phosphorus. First of all, let's establish a relationship of mass, which is the molar mass, to what? Volume. As you can see here, you have 5 moles. The number of moles here is 5. For every 1 mole, you have 22.4. So for 5 moles, we have 5 times 22.4. So it must be noted. Let's do that quickly. 5 times 22.4. That will give us 112 dm³. So the volume of 5 mole of oxygen here is 112. What about the molar mass of phosphorus? Let's do that. Phosphorus is P4. So every mass of phosphorus is 31 according to the what is given. So you have 31 times 4. And that will give us 124. So 124 grams of phosphorus gave us 112 dm³ of oxygen. Yes, this mass requires this volume. So we have established that. Then you now look into the question to see the values given. What volume at SPP will be required for the complete reaction of 12.4 grams of phosphorus? So we are looking for X gram here. Sorry, they gave us a mass of phosphorus, 12.4 grams. So we are looking for volume. So we equate it to X in what? dm³. So what do we simply do? Cross multiply. When you do that, this is what we are going to get. So you have X times 124, 124X equals to 12.4 times 112, 12.4 times 112. We can divide both sides by 124, divide here by 124. This cancel this, X will give us, oh, I know if I divide this by this, I will have 0.1 times 112 will give us 11.2 what? dm³. This is the volume of oxygen required to react with what? 12.4 grams of what? Phosphorus. Let's take our last question for today's class. Finally, we have come to the end of today's video lesson. If today is your first time for coming across my YouTube channel and you are a student preparing for JAMB exam or XSE exam or any of the related exam, please do well to subscribe to my channel and on your notification bell so that whenever we come online to get across to you. Meanwhile, please do not forget to solve this question. Send your answers to me in the comment section. Thank you very much. I'll see you in our next video lesson.